Hello and welcome to our third meeting of CKAD study group. I'm very happy that all of you are here. And just before we begin, I will remember who I am for the people that has joined this meeting for the first time. So my name is Łukasz Tomaszkiewicz and I help developers and DevOps engineers to accelerate their career in the cloud. And actually how I do it? I do it in a couple of ways. I run YouTube channels. First one is the one in English called LuktomCloud/YouTube. You may find some of the recordings from previous episodes and previous meetings of CKAD study group. And I also run a YouTube channel in Polish, which is called CKAD. You can access that on the address CKAD/YouTube, and that channel is mostly focused on AWS, and there is a content in Polish, both on the basics of AWS as well as some of the interview questions, the typical interview questions around the cloud. I also create online courses. So far I created two big courses. The one is course Terraforma.pl, which covers one of the most popular tools for infrastructure provisioning. And the second one is Path of AWS Developer, which covers all the things that every developer should know before starting development in the cloud. Actually, I will post a couple of videos from that course on the CKAD channel, so you may preview what this course is about, and then you may decide to buy the full version of it. I also run on-site workshops regarding Kubernetes, regarding AWS, Terraform, or whatever you like. If you want me to do a workshop for your company, just let me know, just contact me and we can talk about it. Yeah, I create software for a long time when I was a child. I also run two software houses. It was at the times where Kubernetes was not so popular, so actually that's an interesting experience to compare what is happening right now in the infrastructure automation and what happened 10 years ago. If you would like to dive deep, you can listen to the previous meeting when I mentioned something about it. And I also work at AWS Polska and AWS in Poland, the Polish branch, in the ProServe company, and I'm there as a senior cloud infrastructure architect role. And calendar and agenda for today. So as you remember, we meet every Thursday at 5 UTC time. And so far there were two meetings. In the first meeting where I introduced you to Kubernetes and CKAD exam. If you are curious what's the exam like and what you need to prepare before the exam, except your knowledge, you may refer to the first recording from the meeting. And then last week we talked about Kubernetes basics review. So if you do not feel comfortable with Kubernetes basic, I explained how it works, what are the main objects and main concepts of Kubernetes, so you can also find it on the YouTube channel. This is the third meeting, and today we will cover first domain of the CKAD exam, I mean from the official curriculum, and this domain is application design and build. Just to remind you, next week we will do a short break because I will be skiing with my family, and then within 2 weeks time we are back and we will cover second domain of the exam, which is application deployment, and then other things to follow. I hope you scheduled your exam date for March. I think it's the best, after you are fresh with the knowledge and fresh with all the stuff you've just learned. So I highly suggest that you schedule your exam for March. Soon I will record a video on how scheduling the exam looks like. Please subscribe the YouTube channel you are watching me right now, because there will be a video about that, so you won't miss it. As I mentioned, first domain is application design and build, and there are a couple of things that we cover within that domain. So first, it's about defining, building, and modifying container images. So actually, we will start with some basic Docker stuff. We will use Docker to build the containers, and I will show you how to run the containers locally and to test if they are running. Then the second point of this domain is understanding jobs and cron jobs. I covered that in details last week, so we will just remind that, and maybe if the time will allow us, I will show you how it looks like in practice on the cluster. Third thing is about understanding multi-container pod design patterns. So this is a very interesting use case for Kubernetes. And then finally, we've got utilize persistent and ephemeral volumes. So we will talk a little bit about storage. If you have any question, of course, you can write them in the chat. I'm taking a look at the chat every couple of minutes. So when I notice that you wrote some question, I will just stop after the section, and then I will answer your question. So first, we are gonna talk about Docker. Write in the chat, please, if you are familiar with Docker, if you use it, directly to building the containers, and how comfortable you feel with that. In the meantime, I will introduce you on not only the Docker, but other runtimes and other ways to build the containers. So actually, there are a couple of them. The first one is docker build. This is a command that is shipped with the Docker tool, and this is probably the most popular one. However, this is not the only one, because we've got a couple more approaches, a couple of other tools. You can use any of these tools to build your own container, and in most cases it depends on the case. For example, we've got something called Canico here. This is a project that allows you to build a container without running as root. So actually the main disadvantage of Docker build is that you have to have root capabilities. You have to have root access to the Docker. And this is a problem. This is a problem, especially if you run CI/CD systems, because in order to access root and access Docker as root, you need to virtually allow access to the whole system, because if you are able to run a container as root, then you can do anything you want with the host, with the system that is hosting that Docker. So actually, this is some kind of impediment for the very secure, highly secure environments, for example, for financial institutions. And in my career, I used, for example, the previously mentioned Canico to skip that problem, and and to build the containers using just ordinary user account without needing access to root account. There are also other ways. There is also something called Ansible Bender. If you are familiar with Ansible, or maybe you are just porting some kind of solution that you have Ansible automation for that, you may be interested in that project, because it actually allows you to leverage existing tooling using Ansible to just build a Docker container. And then we've got a couple of other methods. I think you can Google details about them. I don't want to spend too much time on that. So basically, what is required to start building the container with Docker is something called Dockerfile. Dockerfile is some kind of recipe that Docker uses to build your container. And as you can see, there are many commands here, many lines in that file. And we will go one by one with this line, but I see that there are some questions in the chat. Which one leaned configuration as well to enforce provide best practices? I mean, Canico is quite cool, because it allows you to, for example, run an isolated container with Canico, and then you can within that container build another container. So actually, it's quite secure, and I think it enforces a couple of best practices. Oh, and you are asking about non-security and distroless. Okay, I will cover a couple of best practices later when I will describe the lines from that Docker file. So first line, as you can see, is a command called from. From command describes and tells Docker engine which basic container image it should use as a base for our containers. So there are a couple approaches here. We can start, with some kind of base operating system like Ubuntu or Debian or Alpine, but we can also use some kind of platform containers, I can say, or framework containers. In the example you see on the screen, this is a Node image. So actually this is based on Alpine operating system as a base operating system for that container, and then there is a Node application installed already in that container, so you don't have to care about installing your own Node distribution or your own Node version. So actually you can just start from the base operating system, or you can use another container that someone or you built in the past. So this allows you to greater reusage of the containers because you don't have to build everything from ground up. This is one thing. And the second thing is that it speeds up running of containers at the runtime. And because, for example, if you are using the same base container in multiple cases, the probability that your Docker engine has already cached that image is greater than, if you are just building every container from a different source. There is a special container or special command called from scratch. This is an empty container. And you may wonder why you would like to, run totally empty container. Does it make sense? I've just said that you need to use, you can use some kind of operating system or framework container to speed up your work. So why start from scratch? Why start from empty container? Actually, there are a couple of use cases for that. For example, they are often used for data volumes. We will talk about storage and volumes in the later part of today's meeting. However, there are a couple cases from my career I used volumes like that. For example, if we needed to deliver some kind of certificates, for example, if you have custom certificates that you need to trust in your application, then you can create, for example, a container with data volume, and that you basically put only the certificates there and reference that certificates from other containers. So this is one case. Other case is, for example, you may build your website that contains some kind of HTML files and other stuff, and then publish is as a kind of package, and then reuse it on some kind of web server of your choice by just downloading both the containers for the web server as well as data container. I will show that example in one of the parts related to the sidecar patterns. Also, from scratch container is very useful if you are writing a software in Go. Actually, I do so I've got some kind of experience with that. And the nice thing about that is you can compile Go to a single binary. So you don't need to have any kind of executable runtime. This is not .NET or not a node that needs a node interpreter to run your application. You can just compile it to the single binary and then just copy that to the container from scratch. So the container has minimal size and is very efficient to download and quickly run on your infrastructure. And then let's go to the second line of our Docker file, which is a run command. As you may figure it out, run command is used to run some commands inside your container. In the example that you can see on the screen, we are running APK. APK is Alpine Package Manager, and we are adding some kind of packages here like Python, G++, and Make. So what I'm doing here, I'm adding additional software to my container. Then we have a third command, which is called workdir. Workdir sets a working directory for your container. So basically, if you run an application inside the container, that application is running within the directory you point here within the container, of course. So basically, for example, if you have all the source code for your application or all your binaries for your application, you can copy them to /app folder and then indicate in the workdir that /app is your working directory, and this is the place that Docker should start looking for your binaries or start looking for your files. Then we've got a command called copy. Copy copies the file from the building environment into the container. As you can see here, we've got 2 dots here, and dot means that we want to copy from the current working directory. This is the directory that you invoke the build command from. And this is a destination inside the container. So actually, if you are executing that after the workdir command, and this will be copied to /app directory. On the other hand, you can specify, the full path, for example, I don't know, /home, looktom files or something else you want to copy to. Then we have again a run command. And you may wonder in a minute why we actually have multiple run commands. Can we, why can't we just chain the commands? And actually the case here is caching. Docker caches every command, and every command is translated to a different layer inside the container. So basically, if you, for example, run first installation of packages like G++, Make, or Python, then actually Docker creates a layer with that files that were installed, and then it proceeds to the next instruction within the Docker file. So if you, for example, you don't change the packages you are installing in the system, but you change the code of your application, and then you are running yarn install, and the Docker is smart enough to figure out that it should, reuse the cache for the general operating system image, as well as use the cache for the run command, but it will run again with copying the files and then with installing the dependencies for your application. Yeah, I will mention that later. Actually, I use copy because it's more bulletproof in most of the scenarios. Sorry. Then we have a special command called expose. Expose is used to tell Docker on which port our application will be listening. To be honest, it doesn't matter. I mean, we can skip all expose ports commands and it will just work fine. However, it's very, very useful to use that expose command, because expose command does 2 things. First, it includes that information into the metadata of the container image. So someone who is running that container can actually read that information and said something about it. And on the other hand, if you are using a Docker run command to run the container, then you may use the special command that exposes all the ports on the host configuration system. So actually, it's easier to operate that container when you are using the expose command. If you remember correctly from previous, or you attended the previous meeting, I mentioned also that there is a possibility to mark that ports on Kubernetes, and this is the same mechanism, the same approach when it comes to telling our users of our container and what's exactly happening inside our container. Yeah, and then we have the complete Docker file. Actually, there is also a link for the sample I'm using here. If you wish, you can copy the Docker, copy that. I will copy that to the chat. You can download that repository, or just a single file with that Docker file, and then you can run it on your computer. And on the other hand, I will show you how to build that thing interactively. Okay, so answering your question regarding the thing, because before we move to the practical example, copy is actually about copying some normal files, I mean local files into the container. However, if you have some additional things like, I don't know, you want to download the some kind of file into your container and then add it inside, you can then use add. On the other hand, add supports, if I remember correctly, tar archives, and you can extract that archives to the container directly. Actually, copy is safer because, for example, if you are using environment variables inside your Docker file, then you can there is a possibility to to inject some unknown code on unknown URL into that add command. So I usually use copy because it's just safer. Okay. Then we have another question, which is a difference between CMD and entry point. Okay, I need to remember some kind of example. Basically, they are not interchangeable. The thing is that you can use entry point to some kind of application. For example, if you have I don't know, AWS CLI, you can point to the binary of AWS CLI on your entry point, and then this way it will start AWS CLI. And then you may add to the CMD some kind of commands that you want to pass as a parameter to that entry point. So you can use one of them, I mean entry point and CMD. Actually, I think I need to think a little longer about entry point and CMD and find some kind of example to explain that better, because out of head it's quite hard to figure out some kind of example. But you can use entry point and CMD are mostly used when you are doing with some kind of tooling that you want to parameterize it nicely. If we have some time at the end, we may create some kind of container, and I will show you the difference. Okay, so let's start with building that command and building that thing. Let me quickly check out the repository and switch to my terminal. Yeah, so I've got some kind of sample EC2 server. I just created that before today's meeting. I hope I've got a Git there. Oh no, something disconnected, but it doesn't matter. It's a fresh server with Amazon Linux, so probably it misses some of the packages, but I have Docker installed and also some kind of Kubernetes thing here. Not with SSH, but with HTTP. That would work. So if you want to try building the container yourself, you can just clone the repository and I paste it within the container, and then we can go to that getting started. And as you can see, we've got a couple of things here. Let me quickly examine what exactly is here. So as you can see, we've got some kind of application code here inside the application directory within the repository, and we've got a Docker file here and other things, for example build sh, which we can write to console and see what exactly is it doing. We won't use it, we will just use Docker. So basically we've got our Docker command. As you can see, there are many commands that you can invoke using that Docker. We will just go one by one, not with all of them, but the most important one that are most useful, especially while we are talking about the building process. And as you can see, one of the commands that interests us at the moment is Docker build. So what exactly happens when we issue Docker build? As you can see, I'm putting a dot here. Dot is very important because dot points Docker build to the context directory. And actually this is the directory where Docker, references to when looking for the files, for example, to copy. So if I were in the different directory, then I need to specify, for example, full path to that so Docker can find all the files properly. As I've got all my files within the directory, I can just, put the dot, which means, oh, sorry, you cannot see the screen. Sorry, yeah. Good. Okay, I hope you are seeing it now. So again, I cloned as you can see, I'm here. I cloned the repository, the one I mentioned before, the one I pasted to the chat. There is a directory with all the files. As you can see, we've got a Docker file we mentioned before, and there is also here a directory with our application, our sample application. So as you can see, there is some kind of package, there are some specs, sources, and other stuff. And I mentioned that we need to issue now a Docker build, and we need to point some kind of context for the Docker. So actually, if we want to build in the current directory, we just specify the dot. If we are, building in some kind of CI/CD system, probably we need to provide a full path. But I can tell you that usually it's better to change directory to the one with the Docker file, because it's easier to debug, easier to troubleshoot. And now we've got some kind of error. Let me examine the Docker file, and we've got here, because probably something changed. Yeah, something changed between the when I prepared the slides originally, because this is from one of my workshop. Let me quickly copy the original Docker file. And then we will see if that works. So actually cut into Docker file, and then we will paste some things related to our Docker file. Now the Docker file is different, and I need also to change one thing. I need to change that I want to copy not from this directory, but from application. The whole application. Let's build it like that. And let's see what happens. As you can see, at the moment there are a couple of things happening. Maybe I will make it even better, bigger. There is a step 1 of 7, and as you can see, Docker puts the command that it's executing right now within our console output. And as you can see, first step is just downloading the base image, the base container image. It's pulling multiple layers of that image, and then moves to the second part, which is installation of additional software. So as you can see, it runs apk add within the container. You can see the output for apk command. And as you can see, it finishes nicely. Then it moves to the work dir. Then it copies some kind of files. And then we've got some kind of error. Oh, okay, we've got some kind of different version of Node probably specified here. Of course, we can, move between the versions. As it said, it needs a version 16. We can try again. As you can see, this time it's pulling the version 16. And also let's remove some kind of dependencies that probably are no longer required. Sorry for that. I did a workshop 3 or 4 months ago about that, and probably something changed since then. But now it works. So what happened here? As you can see, it downloaded a base image for our container. You can see that it doesn't pull it again. So actually we see that it reuses the cache it already has on the disk. The same happens with other stuff. As I changed the run command, it's actually not using the cache. It downloads the make again. And then, it adds some applications files, copies the files, run yarn, and do other stuff. And now, if we run Docker build again, you can see it's instant. It takes a second to again build that container because actually nothing changed. Nothing changed between the invocations of that thing. So it's instant. Now we can see with command docker images that there are a couple of new images that we created. So as you can see, this is the image I created, and this is the second image, probably some kind of partial image we started working with a couple minutes ago. So the container is already here. What can we do next? We can, for example, we can run that container by using the container ID. We just put here. And let's see how it looks like. So as you can see, Docker runs our container. So basically we can now test if the container is running. We can see what is actually happening to that. And you can see that it started the application and it's listening on the port 3000. Okay. So this is basically it. Let me quickly see what else we have here. And now let's do one more exercise, and that exercise will be actually changing something within the Docker file, or maybe changing something within the application. For example, let's go to the application directory and then go to src and open some kind of file like index.js, and let's just add, some kind of console log hello from Docker. It doesn't matter what exactly is happening here. It just matters that, I changed the file, so Docker will discover that. And now let's go back to our main file. And we can use it and run it and build it again. So as you can see, it reuses a couple of first instructions. So it's using the same basic image, so it reuses the cache. Actually, I haven't changed anything here regarding the installation of additional software, so it also reuses the cache. And then we've got the work dir, which also didn't change. And then we have a copy, and as you can see, actually here it copies the file, and then Yarn actually detected that something changed and something needs to be executed again. So as you can see, that command was run again. It's not reusing the cache, it's actually creating a new layer and executing it again. And now if we were to inspect images, we see that we've got a new image ID. This is, a new container version and new container version that we can use to run it on our infrastructure. So we will run that version of container. And as you can see, we have in that new version, we have hello from Docker. So actually, as you can see, it incorporated all the changes we have and started running the new version of container. The beauty of containers is that, you can use multiple versions on your infrastructure, of course, as long as your application supports that. However, for example, if I say I decide that the new version is not working for me, I can at any time, roll back to the previous version and simply run the previous version. And this way I'm running the previous version of the container that actually does not have that hello from Docker line. So as you can see, building Docker files is quite easy. And then let's maybe play for a couple of minutes with CMD and entry point. So as you can see here, we've got something called CMD. We are using a binary called node, and then we pass some kind of default parameters to that container. And why it matters? It matters especially if you want to pass some kind of custom things to your container. So I can go here and I can, for example, run maybe let me show you a help for that command and what it's capable of. So actually, as you can see, you can run docker run, then specify the image. This is what we did a minute ago. And then you can specify and override the command for that. So for example, I can do something like that. I can do docker run and then, for example, put sh. I need to add 2 more things. So actually it allocates a terminal for me. So as you can see, if I specify some kind of custom command like sh, it's running a shell for me within the container. So I actually overwritten my command for the container. On the other hand, if I want to prevent something like that, I can actually do something similar, but using entry point. And here I can specify node, for example. Let's do it like that. And let's pray it works. And just for the sake of the demo, I will also create a file within the application directory called demo.js. And here I'll put okay, like that. Now let's build the new version of container and see what happens. So basically now we pointed that node is an entry point for our container, and it should always be used as that entry point. As you can see, this is the identifier of a newly created container, so we don't have to go with Docker images. We can just read it like that, and we can do Docker run that new version of container. And basically, in the normal use case, when we don't specify anything at all, you can see that it runs with the default settings we put there. And by default settings, I mean entry point as well as the CMD. On the other hand, now I can specify something like that, demo.js, and you can see that it ran with my custom file I've just recently added. So the difference here is that if you specify the entry point, and that all the parameters in the run command are passed to that entry point. So basically you have no easy ability to override the binary that you are running. So this is, very useful if you want to limit potential users for running, random commands inside your container. So this way you can do it like that by moving the binary to entry point, and this is for enforcing some kind of behavior. That kind of things are especially important if you are running some scripts at your entry point and you want to enforce that, for example, input is validated or the script is important from the point of view of, I don't know, creation of some resources and other cases like that. So just to remind you, this is, just passed there. If I, for example, specify sh here, as previously we did that, it's not working. Why? Because sh is passed as an argument to node. So basically, this is just an argument for node, and node doesn't understand what sh is. And as you can see, we've got error from node. So I hope it clarified your vision a lot, your knowledge about entry points, at least a little. Okay, let me go back to our presentation because we've got 40 minutes already passed and we've got three domains to go. So the second part is related to jobs and cron jobs. Of course, if you've got more questions about Docker, just write them and we will go back to them at the end of my presentation and at the end of our meeting today. Just a quick reminder about jobs. Jobs are used for running some one-time jobs. For example, if I need to run something on my cluster, I need to do it once, then the job is a perfect place for that. It's also nice if you need to ensure that some percent of the tasks completed. So, for example, I may set that 100% of tasks needs to be completed, and then Docker ensures and retries all the jobs all the jobs until they are finished successfully. We can do some kind of parallel running on the containers. So actually jobs are also a nice way to run some kind of batches. If you need to run, for example, processing of the queue and process it as soon as possible, and then you can, for example, run as many jobs as the items in the queue, and they can process, every job will take one item and then process in parallel. So it may be very, very efficient. And use cases, from my point of view, DB migrations is one of the most important use case, because if you follow 12-factor app methodology for creating your cloud native infrastructure and applications, then you probably want to run migrations as one-off job, not as a part of startup procedure for your applications. Then we have one-time setup jobs. For example, if you need to install something on the cluster, or maybe, I don't know, generate some kind of certificates, or maybe SSH keys that are, just needed once, job is a perfect place to actually run tasks like that. And then batch processing, which I just described. Of course, you can use jobs for some admin task. I don't know, if you want to run some kind of backup of your database just once, or some kind of restore of the database once. This is also a good case for the job. Just to remind you, and this is a job manifest, we've got API version and kind I mentioned last week. And then we have some kind of template that we can, specify the pod and that will run. And then we have how many times we want to retry that job in case of failure. Just to present how it's working in practice, let me quickly create a file with that job, paste all that code to my file, and then let me quickly see if the cluster is running. Yeah, it's running. So now I can apply that, kube control apply from file job. And this way we can run our job on the cluster. It's applied, and now I will use the tool called K9S to see what's happening here. So as you can see, this is a list of the pods. As you can see, there is a pod for our job. This is this one, PI, and some kind of random ID for that. As you can see, currently it's in a container creating state. And as you can see, it's running, it's calculating our PI number. And then finally, after completing, oh, sorry, you are not seeing that. Oh, sorry, I forgot to, change, because I need to, do some kind of keystroke for changing the visibility of different parts. Sorry again for that. I'm totally forgetting about that. And so let me do it again. No worries, and we can repeat that. So what I did, I saved the file from presentation from what I'm pasting. Here is just the code from the slides. As you can see, this is, all YAML file needed to run the job. What is backoff limit? It's basically how many times Kubernetes retries that after failure. So if there is any error here, then Kubernetes will try to create that, and it's called backoff because there is an algorithm that, for example, it repeats by default, if I remember correctly, after 1 second, and then if it fails, then after 2 seconds, and then after 4 seconds, and it's, growing exponentially. And actually, this is a default behavior for most of the errors inside the Kubernetes, and you may find that backoff settings in different situations and in different objects inside the Kubernetes. On one hand, it's kind of good thing. It's a good thing because it prevents the cluster from running and using all the resources. But on the other hand, for example, if you find out that something is not working after a long time, then it takes a long time to actually repeat that thing to check if you fix that. Okay, so I applied that to the cluster by using something like that. And then I'm running a tool called K9S. And we will see in the minute. Oh, sorry, I need to delete that job first. Maybe I will show you how to do it here. Let's delete that quickly. And now we are applying our job. Let's go to pods. And as you can see, there is a container here. It was running quite quickly for a second of two. And now it's in the status completed. And what we can do about that container, we can do a couple of things. By the way, that tool is really, really nice. For example, I can go to that line and press Y, and I can see the YAML for that specific pod with some additional stuff. I can also go back using escape and then press D, and then you have a nice description of that specific object on your line with some very, very nice formatting here. So as you can see, this is working like that. There are some Kubernetes events, so you can see at what time all the things happened. And then if you press L, you will see the logs for that container. As our job was about calculating a pi number with some precision, you can see it outputted a pi number to the log. So you see it completed by successfully calculating that. So it was a job, and as you can see, all that pods are here. If you don't need that, you can delete that pod, that completed pod, because, you know, after a long time or many usages of that pod, it will simply, you know, take space here. So I just press Ctrl D and then do it again. The important thing is if you change something to your job, let me maybe quit there and see and check something here. Maybe let's run not 2000 but 5000, and then let's apply that again to the cluster. I changed something. Yeah, and the thing is that the jobs are immutable. So as you can see, I've got an error that I tried to edit something that is immutable. So if you actually need to run a change job, you need to remove that thing. And you can do delete f job. So actually I'm removing that existing object from the cluster, and then I can apply it again. And this way you can see that it will run again. This time probably it will be running longer because I asked them for a greater precision. So as you can see, it's running and calculating that pi number. We can preview the output, but there is nothing on the output yet. So it may take some time. I have no idea how long, to be honest. Yeah, as we are waiting, I will just, oh yeah, it's completed. And now we can see the output. As you can see, it's quite precise pi number. So it's important, especially on exam, that you are not trying to edit the existing job because it's immutable and you cannot do that. You need to remember that you need to remove that object from the cluster first and then apply it again to basically have it working. Okay, let's go to my presentation. Cron jobs are the jobs that are running by the schedule. You can set the schedule for the cron job, and then it's running automatically every interval we specify there. Sample use cases, backups. For example, we want to make a backup every night, and some admin task. I don't know, cleaning old not used containers, or maybe removing the old jobs, or I don't know, restarting some kind of services every now and then. This is a sample manifest for a cron job. I think I won't run it because, this is the same stuff as we did previously. We've got some kind of question here. Can we use a job to run a command to terminate or edit other pods based on certain condition? Yes, we can do it, but it's not that easy. I mean, you need to create or use some kind of container that has kubectl within, or maybe install that tool inside the container. Then you need to create some kind of service account to allow that specific container service account and role and role binding and all the permissions required to modify that containers. And then after that, you are of course able to do that. And you can act, from within the container to manage other pods. And I did it in the past, and it's working, just fine. Yeah. Okay, so it was so that part was about jobs and cron jobs. As I mentioned last week, you need to make sure that you know how this template looks like, because you've got multiple levels of nesting here. You've got spec, job template, spec, job template, spec, and then you've got a specification from container. So this is like that. I'm looking for one thing because I want to show you one trick, but I don't remember that from memory, to be honest. But there is a trick that you can actually create some kind of resources by using, very. I'll find that later and show you next time. Because there is a command in kubectl that you can actually create a sample manifest like that. So it's very very useful during the exam, to be able to quickly generate things like that. Okay, so we've got 50 minutes already of our meeting, and two more domains, or two more topics to cover. But these are quicker ones, so actually don't worry. It will take a couple dozen of minutes, but not too long. So third domain is third topic is understanding multi-container pod design patterns. So what is it about, and why we may want to run multiple containers inside the pods? There are many use cases. First one is it actually extends the features of application. So basically, if our application needs some kind of additional functionality, we can offload that functionality to the infrastructure. The great example of that is, for example, implementing mutual TLS, which can be, cumbersome in some cases to implement inside the application. But on the other hand, you can, create something like service mesh on Kubernetes, and then you've got that covered, and it's basically using that patterns. This is quite advanced stuff, so I won't go very deep into service mesh. There will be just one example of that, but this is not required for the exam, so take it easy. Use cases I used for multi-containers situations and patterns are also related to managing the data and configuration for containers. One of the examples is actually if you need some kind of secrets inside your containers, but for example, you need to download that secret from external services. Now we have something that is called external secrets, but a year or 2 or 3 ago, when I worked for one of financial institutions, they had a requirement to get secrets, from the central secret store, but there were no capabilities on Kubernetes at that time to do it with, the generic secrets inside the Kubernetes. So actually we used additional container inside the pod to just download the secrets for the application. Also, if you have some kind of containers that have the same life cycle, for example, if you've got, something that processes your logs and then your application, then you may want to run it inside one container. Also, if you have some kind of integration between containers that, needs to run one to the other, that's also a good case of multi-case container. And there are a couple of multi-container setups. And there are two types of them. One is init, I will cover that later. And then we've got a runtime. And regarding runtime, there are a couple of common patterns. Actually, most of the sources are providing a free of them, and there are a couple more, but we will focus on this free one as they are most useful for the exam. So this is sidecar, adapter, and ambassador pattern. Before we go to the sidecar pattern, I will answer the question from the chat. Is an exam about containers parameters like probes and their parameters, running some command before container starts, sharing processes namespace between containers? Yeah, actually, this is the topic for the exam, you know, to share things like volumes between the containers. I will show that in a minute. Sidecar pattern, what is it about? So we have our main application, and then we have some kind of helper container for our application. The thing is that that helper is not essential for our application. And by that I mean I can run my application standalone, but if I want to add some kind of features that, you know, my application does not cover, and I don't want to modify that application, I can do the same functionality by simply using that sidecar pattern. The important part is that, you know, the sidecar is usually not at all related to the application itself. So it's using some kind of data from application or some in other way integrating with the application, but it's not an integral part of the application. Sidecar pattern usually shares the volume between the containers. I will show that in a minute. And use cases are, typical use cases are logging. So our application is writing a log to a shared volume, and then sidecar is processing that logs in some kind of way. Monitoring agents is also the thing that we may want to run. For example, we've got application that, I don't know, accept some kinds of uploads from the users, and then we may have a sidecar container with antivirus software that actually, you know, scans that software as they come to our container. And also syncing data. There are applications that, you know, for example, need to have some kind of shared data volume, but there are situations where you cannot use, for example, a networking file system, and then you need to sync data between the nodes. So this is also the case. I once used also syncing data using Git. Actually, we had a setup where we deployed Grafana dashboards directly from Git. And actually some of the containers, you know, updated automatically using sidecar pattern and syncing data using Git fetch, Git pull. And the example of sidecar data container, here we've got our main container. This is Nginx. This is a web server that serves traffic. And then we have a second container, which is basically my data container. Here I'm, you know, pretending that I'm syncing some data, but as I said, it may be anything. For example, that script can look for new versions of website to serve, and then it may download that thing and update on the local volume. And as this volume is defined here as shared volume, the data can be shared between, you know, my container and Nginx container. So basically, this container is downloading new versions of data, and this container is serving the data that the other container downloaded. So this is, you know, one kind of example of actually creating something like that and sharing between the containers. And then we have adapter pattern, takes output from app and sets it somewhere in standard format. This is, you know, all about converting the format. So for example, if you've got your application that uses some kind of internal format for, I don't know, logging or monitoring, then we may want to use adapter pattern to translate our format to some kind of common thing. The great example of that is Vault. Vault is a secret manager that you can install on your Kubernetes to safely store your password. But the problem is that Vault uses a format called statsd. And basically, the software for monitoring, the very popular software for monitoring for Kubernetes called Prometheus, cannot use that statesd format, because it does not understand that. And the simplest way to allow monitoring using Prometheus for Vault is to just add another container that, does a translation of that things. And this is the example of that. So we've got a deployment and we've got a container specified here that uses an image like that. And as you can see, this container exposes its own port, and on that port it exposes metrics in Kubernetes format, in Prometheus format. On the other hand, it connects automatically using the default port of 8200 and simply connects, from that thing to the Vault container. Let me maybe quickly do it with whiteboard just to depict that. So we've got Prometheus here. I need to connect my tablet probably. And then we have our pod. This is our pod. This is our pod. And then we've got one container. This is Vault. And then we've got that sidecar container here. So basically, because Prometheus cannot connect directly here and understand statistics and metrics exported from Vault, we need to add that sidecar container. And what that container does is actually it connects to Vault, gets some kind of metrics, and then we can use Prometheus to just point it to the sidecar container, and Prometheus asks that sidecar container for the metrics in the format it understands. So this is about adapter pattern. There is also a second pattern called ambassador pattern. Let me quickly move to that. And this is very similar, but on the other hand, it's for egress traffic. So maybe let's move to use cases, and I will show you how it works. So there are many cases, especially if we migrate legacy applications that, for example, it has localhost specified as a database. And in that case, we need to somehow, point to the external service. So we can run another container that just acts as a proxy and points to the external database. And in this case, we can simply, overcome the obstacles of hard-coded localhost address. Other use cases are related to, for example, service mesh and mentioned here securing connections. Our container just connects, on localhost to the different container and then connects in the secure manner to other containers. We've got some question. I mean, I understand that sidecar and adapter and ambassador are all basically the same. I mean, it's all about running multiple containers next to each other. However, for the sake of Kubernetes underlines that, sidecars are usually something that shares volume. This is the characteristic of sidecar, and usually adds some kind of additional features here. My understanding here is adapter is, for incoming traffic and, connecting from adapter container to our main container and exposing something externally. And ambassador pattern, as I mentioned, is for egress traffic. But to be honest, in my whole career, we never used words like ambassador, like adapter, or we just use sidecar for everything because, everyone understands what sidecar is. And usually you don't need to dive deep and, think about ambassadors and adapters. I mean, we use it interchangeably depending on the use case. Yeah, so yeah, I see you. So I think I answered your question. And then we've got we've got another question. What would you propose a light container and easy to configure MTLS with ambassador pattern? You can use Envoy. Envoy is quite comparably easy to set up, I can say. I mean, you can use Envoy, of course, as a part of big service mesh, but you can also use it as a standalone proxy for things like securing connections. And this is an example of, for example, service mesh using Istio, Istio, yeah. And what you have here, you've got pod. Pod is running some kind of container called here as a service A, and there is some kind of proxy over there. And as you can see, that proxy communicates with all other stuff, and it handles ingress traffic, egress traffic, and all other stuff. And basically using that pattern ambassador in case of service mesh, your container is only communicating with that proxy by using the local host, and then all the stuff is handled by the service mesh. Okay, so that was all about runtime containers. And there is also a second kind of containers called init containers. And init, the main characteristic and something that you need to remember is that they run before all our main containers. So basically, they use the same definition. Okay, of course, you can use the same container image, different container image, you can specify whatever you want. But the key here is they run before your containers. And what are the use cases? For example, configuration generation. This is quite popular. I implemented HA proxy cluster once. And what we did actually, we had it was the migration from a console-based infrastructure. So what we did, we asked console cluster for the configuration, and then in init container we created a file with the configuration for AJ proxy, and then passed it using the shared volume to the AJ proxy as, you know, the configuration for a runtime. So this is for that. You can also use it for secrets fetching, and that was the case I described before. So you can, you know, use that init container to download some kind of secrets, some kind of certificates, or anything that is needed for your applications to run. And it's happening before your application starts. So this is very important. You can also pull some kind of data for your container. For example, in the example of Sidecar, if we don't need to sync that in the continuously, we can, for example, just download the newest version of our website, put it in the volume, then exit init container, and just allow Nginx to run that. Init containers are also sometimes used for installing tools, especially in the ad hoc manner. For example, if you want to troubleshoot something, but you don't want to, build the whole container, ship it to the cluster, and do all that kind of stuff. I'm guilty. I did it multiple times, to just use the init containers for downloading the tools, sometimes building them and then shipping, to the main container just as a troubleshooting way of troubleshooting. This is then an example of init container. As you can see, it's similar in the definition here. You can use all the fields that you use for a regular container, but the only difference is it's init containers. So under init container stanza. So basically you are just writing init containers, and these containers, all containers, because there may be multiple of them as well, they are all, executed, and after all of them are successful, then the main container is run. And there is in Kubernetes something called lifecycle hooks, and this is similar in the terms that you can run something at the start of the container, but there are a couple of important differences. Okay, so we've got init containers, and init containers can use separate image. So this is, something that distinguishes lifecycle hooks and init containers. You can use different container image for the init container. They run before main container, so actually all the init containers needs to finish successfully, and then the main containers is run. Its use case is when the order is important, and by that I mean you need to have that container on that job or that command completed before you start your main container. For example, if your application requires a certificate to start, then you want to use init container instead of lifecycle hook. On the other hand, lifecycle hooks are using the same container. You can point lifecycle hook only in the context of your container. And they are running after the container started. So basically it's all about, your container is running, your application is starting, and then in parallel, Kubernetes runs that lifecycle hooks to install, to do the stuff you need. And what sometimes, some kind of issue here is lifecycle hook runs within your main container. Because of that, it uses for example, the user that is inside your container. And that's sometimes a problem. For example, if I'm running as a limited user, because this is a best practice to not run your containers as root, then you may find yourself in the situation that you, for example, cannot install anything new inside the container. So this is kind of the problem with lifecycle hook, that you cannot, for example, use another user for that. Okay, and this is an example of lifecycle hooks. As you can see, we've got a sample container here, and then we've got a stanza of lifecycle, then we've got post start, exec, and then we can specify a command, and it can be any command that is available within your container. So this is how it looks like. By the way, there is also a second lifecycle hook, press stop, which is run before your container terminates, but this is out of scope for today. Okay, and I've got a question. When init container starts, only during the deployment. I mean, deployment creates a pod, and so it runs in the context of your pod. So actually, if you have multiple replicas of your pods scheduled on the different nodes or the same node, it doesn't matter. Then all that things run when the pod starts. So actually, Kubernetes creates a pod, downloads all the images, run the init container, waits for the completion of init container, and then runs your main container. So actually, if you, for example, scale to 0, there are no init containers run. This is not a characteristic of deployment or something else. This is a characteristic only on pod. So actually, when pod is created, then we go with init containers. And just as the last word here, of course, you can combine lifecycle hooks and init containers. I mean, you can use lifecycle hook for init container, but this is not obvious, and please don't do it. Okay, and last topic. This is quite complex one, and hopefully, because this is CKAD exam, we don't need to dive so deep. However, I can say that volumes are sometimes more complicated than all other areas of Kubernetes, like, compute, or no, networking is more sophisticated, I can say. And the complexity comes with both the number of storage as well as number of mechanisms to attach that storage. So basically, Kubernetes, started with some kind of built-in storage drivers, but then they moved to the external provisioners, and then now it's moving to something called container storage interface, and and it creates some kind of complex additional complexity to understand the storage. But regarding our exam, we need to understand that there are a couple of basic types of storage. There is something called empty-dir, which you saw before. I showed that in the context of sidecar. This is just a temporary directory that is created somewhere. It's managed by Docker. It's created somewhere on the host disk. But actually, after the pod is terminated, that empty-dir is deleted, and no data is left behind. Is left on that empty-dir. There is also something called config map. Config map config map actually provides a configuration for your application. And config maps are also not something that is, stored within the pods itself. Config maps are stored in the Kubernetes control plane in etcd, which is a database in Kubernetes. So we don't consider them as, as permanent storage. This is also some kind of ephemeral thing, but I will cover that in a minute. Then we have a secrets, which you already know, which I mentioned before a week ago. And then we've got CSI ephemeral volumes. You need to know that there is something like that, like CSI ephemeral volumes. It's up to a container storage interface, CSI, to decide if the volume is ephemeral or not. So it's quite complicated. There is also something called host path. This is just mapping of the local disk of our host on the node to the path in the container. We don't use that in most of the cases, but I will cover that in a minute. Then we've got PVC and PV, which is persistent volume claim and persistent volumes. Also, we will talk about it in a minute. There are some kind of questions here. What kind of volumes do we need to know? PVC and PV storage classes, localhost, or all options? Basically, these are the ones I mentioned before. I mentioned on the slide. And I'm not sure, but we don't need to have that CSI storage driver. But I think it's good to know that there is some kind of mechanism called CSI storage, because it's important in practice, I can say. Config map, quickly, we store configuration within the config map. It's just a key value based. It's limited by size. Oh, this is very important. And this is also one of the reasons that we may want to use something like init containers of lifecycle hooks, and because config map can only store up to around 5 megabytes of data. And this is a limitation of underlying database of Kubernetes, which is etcd. Sometimes you may find that you may store even less. For example, if you are using kubectl, it creates a special annotations last applied configuration, which is a copy of previous version you applied. So it actually can reduce by the factor of 50% the available storage. So in case you need something bigger, you need to provide some kind of very, very long and big configuration. Probably you need to use init container for that. Config maps are, this is interesting part, dynamically updated. So for example, if you use a config map in your pod and then you edit that config map, it automatically gets updated within your pod. And this is a place where you may find sidecars as well. For example, Prometheus uses a special sidecar container that just watches the configuration. So it watches if the config map is changing, and when config map is changed, it reloads the configuration in main Prometheus in main Prometheus container. So this is also quite popular pattern in Kubernetes. This is an example of a config map. As you can see, we've got some kind of epi version, kind, and other stuff like that. Then we have data, and then we have key value pairs. This is a key. And then there is a value. Pipe here means that this is a multi-line value, so you don't need to put /n to indicate end of the line. You just put pipe and then indent that by 2 spaces, and then you can specify the file. And by the way, I highly encourage you to read more about YAML. Maybe I will even create some kind of additional tutorial about YAML, because there are many tricks that you can use in YAML, like this one, but there are more tricks, but it's out of scope for today. And you can, as I mentioned, you can mount that config map to your pod. As you can see, you're just adding volume mounts. You specify the name of the volume and then mount path for the volume. And then in the volume section, you specify again the name of the volume, and then you can reference to the config map, to just point which keys should be mounted inside your volumes. And the thing here is that the key becomes a file name and the value becomes a file content. So you are basically seeing a config map as a list of files. What parameter control refresh of control map? How fast control map is refreshed? Basically, it's all about watching. I mean, there is a component called kubelet that communicates with API gateway of Kubernetes, and it runs in the watch mode, and it should be, quite quick and propagated quite quickly, to the kubelet to update all that things. I don't know if there's any parameter, to actually enforce that, because usually the things in Kubernetes are that multiple components are just watching on API server for changes. So when change happens and is propagated across API server, it should be, kind of pushed automatically to all interested parties. So this is, not a refresh based, but something like pull based or watch based. Then we have secrets. They store sensitive data. And the reason here is that we don't want to put the secrets inside the definition of deployment or pod, because they may leak, someone may see that. So it's better to put that in the separate object, especially that by default it's encoded by base 64, so you cannot easily read that data. Humans cannot. But by default, in most Kubernetes deployments, they are not encrypted at all. There are some ways to encrypt that, to enable encryption, but they are not by default. This is an example of secret. As you can see, it's similar to config map. The only difference here is, of course, API version and kind. But the thing that data is here is written in base 64, but the idea is the same. You can mount secrets as volume, as you can see here. But you can also mount a secret as environmental variable. Just one remark here, you can also do the same for the config map. You can mount a key from config map as an environment variable, and the mechanism is similar. We just need to do a reference from config map instead of secret here. So this is it. Then we have a host path. As I mentioned before, we usually don't use host path because host path is anti-pattern. Kubernetes is all about scheduling, dynamically scheduling resources to different nodes. And using host path, we are not sure on which node our volume will be launched. However, it has some use cases. For example, I worked on the project on Raspberry Pis when we run Kubernetes on the edge devices, which is Raspberry Pi and similar. And then we used host path, to just, for example, install the licenses that user inputted or do other stuff like that. But that was the special case because, there were no cluster of Kubernetes nodes. There were a single machine, and Kubernetes was not used for the scheduling itself, but more for the things of updating and orchestrating other things. We have emptdir, which I already shown. And we have some question. A bit mixed, kubelet pull or any controller notify kubelet. As I said, kubelet is actually, watching the changes to the object it's interested in. And by object it's interested in, things related to, for example, config maps, as well as pods related to the labels it has to allow scheduling of that specific pod. So it's quite common mechanism to watch for that changes. For example, if you've got any other controller like Cloud Controller Manager or Kube Scheduler, they are basically running in the same manner. They are also connecting to API server and then watching for the changes they are interested in. So it's quite quick, I can say. I've never had any issues with updating config map, but I can say you one thing, updating config maps are not a good thing in most cases, because if you update your config map and do some kind of mistake, you can crash your application, and this is not good. I believe in something like that. When you deploy a new version of configuration, you should do a new version of deployment, and then, for example, deploy new config map with new name of that config map. And this way you force deployment to issue a new version of your application with new configuration, and it gives you a reliability, operational reliability, and ensure that your application is not going to fail due to any kind of error within the configuration. So I actually try to not depend on the update mechanism of config maps. It's better, to create another one version of config map and then update that in deployment. Okay, back to our topic. One of the most important aspects in Kubernetes, but also one of the most confusing one, is PVC and PV. This is to deliver storage in the elastic manner. You can think of it as a pod and a node. Let me quickly maybe go to the whiteboard. So, sorry, how can I move it? I need to do like that, and then I can write something and draw something. So basically, we can think of Kubernetes as two things. If we are talking about compute, okay, probably I should type that. We can think as a pod as something that requests. If we need a compute capacity, we can think about pods. And when we think about, providing a physical resources to provide that compute resources, then we have a node. So what Kubernetes basically does is it matches pod to a node, assigns pod to a node, to fulfill that request and, provide capacity for compute. And when we are talking about storage, we can think that this is very similar. So basically we've got persistent volume claim on the demand side, and we've got persistent volume here on the supply side. And what Kubernetes does in that case is it also try to find and fulfill our request, which in that case is PVC. So Kubernetes tries to create some kind of persistent volume or just match existing persistent volume and then assign one to each other. And this way we can provide storage for our users. So you can think about that in terms of demand, and then on the other hand on supply. I think on my workshops it helps many people to to switch mindset of Kubernetes, that from very complex thing to just two sides. There are objects for request and there's objects to fulfill that request. Okay, let's go back to my presentation, and we are going to finish soon. There are two kinds of persistent volumes. There are static ones and dynamic ones. Static ones are usually you can encounter there on the on-premise world, where you need to provide some kind of storage. And on the other hand, in cloud environment, you've got something called dynamic persistent volumes. And usually there is some kind of provisioner. This is a special controller that looks for PVC and then provisions some kind of storage in the cloud. So this is for dynamic persistent volumes. Important thing to know about persistent volumes. You can set if you want to reclaim that space after deleting the PVC. So basically, if you know that you don't need that storage after deleting of PVC, you can set the policy of reclaiming to delete, and then persistent volume is deleted. On the other hand, you may set that to just leave it, and then persistent volume lives on the cluster until someone manually deletes it. The question, if PV is 10 gigabytes, PVC can be 5 gigabytes for one pod. Let's say it different. In most cases, In most cases, it depends on the storage class and the provisioner. I mean, there are rules each per provisioner if this is possible, but as a rule, yeah, it can be much like that, especially in the on-premise world, and especially when you manually bound that persistent volume to PVC. There are also cases for resizing that, but this is quite advanced, and you can, request resize of the persistent volume and do all other stuff. As I said, storage is very, very broad topic. For example, if last version of Kubernetes, you've had ability to create a snapshot of the persistent volume, which is a great way, to making backups, but this is out of scope for today. PVC example. A couple of important things here. You've got something called access modes. This is very important because it determines how many pods can use that storage. There are a couple of ways. There are read write once, and there is also read write many and other things. It may be important for the exam to know them and know the limitations of them. For example, if you are using something that is backed by EBS in AWS, it means that it's read write once because one pod can use it at the moment. On the other hand, if you are provisioning something on the network file system, it's probably read write many. So it depends on the specific use case. It depends on the provisioner as well as storage class. And different storage classes and provisioners provide different access modes. You can access a volume as a file system, so it's automatically formatted and file system is created for you. But you can also request a block device if you want to manage that volume by yourself or create a very specific file system on that volume. You can also request a block storage. Then we have something called resource request. Here we can put how many gigabytes we need. And there is also final parameter, which is called storage class name. By using storage class name, storage class name is a way that we tell Kubernetes which provisioner we want to use underneath. And which parameters we want to use for that specific provisioner. Let me quickly go to the whiteboard and draw that for you. Which option to use? If you are using the cloud and you are using dynamic provisioning of resources, this one. If you are using cloud and dynamic provisioning of resources, this probably doesn't matter for you because it will be always matched because cloud provisioners are automatically provisioning as many gigabytes are you request. So this is it. Maybe not with red. We've got a PVC here, and then we've got PV. As I said before, this is, Kubernetes works like that by assigning one to the other. But underneath there is a storage class. PVC points to some specific storage class, and that storage class points to a specific provisioner. And that provisioner physically creates that persistent volume. So basically by specifying PVC, Kubernetes checks the storage class, then sends that to a specific provisioner, and after that provisioner creates a persistent volumes, returns that persistent volume to Kubernetes, and then Kubernetes can match one with each other. So basically there is something like that. Can we connect on PV with two PVCs? Yes, we can do it, but it depends on the provisioner. So for example, if you've got network file system and you provision some kind of resources on that network file system, you can specify a persistent volume on that network file system, and then as it supports read write many access mode, you can reference multiple pods from multiple PVCs to the same persistent volume. On the other hand, if you've got EBS storage, which is disk share screen, sorry. Yeah, again, Again, sorry. I will explain that in a minute. I just finish explaining that. So if you've got, for example, EBS storage, which is assigned to a specific node on AWS, then it cannot be shared with multiple pods because it's bound to the single instance. But there is one trick: if you have multiple pods on the one instance, then they probably can share one persistent volume, but it's out of scope and it's not supported officially. Just to describe it again, as I said before, Kubernetes tries to match PVC with PV, but to do so, it needs to read the storage class from the PVC. Then find the corresponding storage class object within the storage classes defined on the cluster. And that storage class contains a couple of things. It contains things like, for example, a tier for the storage. I mean, you can create multiple storage classes. For example, this one is cheap one, this one is expensive and very fast one. And they all can use the single provisioner to create that persistent volumes. So it's quite complicated, but for the matters of exam, I think you only need to understand the general flow of that. I don't expect any kind of troubleshooting related to the provisioner itself. Probably, most of the question will be related to just create a PVC for that and to create persistent volume. Yeah, let's go back to our presentation. And this is a way that you mount a volume inside your pod. This part, as you can see, is the same as with all other storage. And the only thing that changes is the volume stanza, and by using a persistent volume claim and then referencing some kind of the claim. Yeah. So this is it. And that's all for today. And it's good because, my throat is hurting me right now. Just to remember, we will meet next time on February the 16th, and we will cover things related to application deployment. So probably there will be more demos, and I will try to create some kind of demo with PVCs as well, to show you a couple of edge cases. And I think it will be quite fun to run that. Then we are meeting on the 23rd or 3rd of February, March 2nd, and finally on March 9. And I can say that's all from me. If you have any question, you can write them here or just write to my email. If you have any suggestion what we can do, my one thought is that probably we need to split into more meetings because hour and a half is quite hard to to talk constantly. On my on-sites, I usually do 45 rounds and then 15 minutes of break, but it's not good approach for online meetings. So probably more meetings, but a shorter one. But maybe for the next edition of that. So if you don't have, there's of course some kind of delay here with sharing the screen. So I will wait a minute or two for your input. If you have any ideas what can I record on the channel, on my YouTube channel, then just write down here maybe on my mail, because I'm preparing for write a couple of demos about Kubernetes, about installing the cluster, training cluster, as well as using some kind of online tools for that supports learning. But if you've got any ideas and something that you find valuable to see a demo of, then just let me know. And after my break, maybe I will be able to finish recording of that. So thank you for today. If you have any questions, just write email, and have a nice evening, and see you within 2 weeks. Bye bye.